All right, so Module 10, we're going to be talking about circles in this module, and this first lesson is about circles and circumference. So there's some vocabulary that we need to talk about right at the beginning. When we talk about a circle, that is the set of all points in a plane that are equidistant from a given point, called the center of the circle. What does equidistant mean? Equal distance, same distance away. One full revolution around a circle measures 360 degrees, and a circle is named by its center. So, for example, pull that back. If I have a circle like this, this would be called circle R. A radius. This is a segment that goes from the center to a point on the circle. So like this. Or this. Or this. And all of those segments that go from the center to the edge of the circle are congruent. Each one is a radius. A diameter is a segment that goes across a circle through the center. So like this. From point A to point B and through the center. This segment AB that I just drew is a diameter. Because it goes all the way through the circle and it goes through the center of the circle, so we have two segments that go from the center to the edge. There's one that goes from the center out to A, one that goes from the center out to B. So the diameter is equal to 2 times the radius. And the radius is equal to the diameter divided by 2, or you could write that as 1/2 diameter. Two are two radiuses. Do you see how on the circle up above we have them labeled as R? That is the length of the radius. Length of the radius. 2 times R, yes. Because you have two radii. This right here is a radius, and this right here is also a radius. So the diameter is made up of 2 radii put together. A chord is a segment whose endpoints are on the circle. So a chord is any segment like this, where the endpoints are on the circle here. Well, aren't the endpoints of my segment on the circle with my diameter? So this segment AB, we can call that a diameter. That is absolutely correct. But it is also a chord, because it also meets the definition for a chord. Its endpoints are on the circle. And then we have concentric circles. These are coplanar circles that have the same center. So this always kind of reminds me of a target. Concentric circles would look something like this. Same center, but different radii. All right. Let's see if we can use some of this vocabulary now and apply it to answer some questions about circles down at the bottom of the page. Same center, different radii, yes. All right, number 2, use the figure to the right to name the circle and identify the radii, chords, and diameter of the circle. What would the name of this circle be? Circle X. So you can write it like that, or you can draw a circle with a dot in the middle to represent the word circle. So either one of these would be correct ways to name this circle, either with the word circle and then the center X, or you draw a picture of the circle with the center marked and then X next to it. There are 4 radii shown in this figure. Remember, a radius goes from the center to the edge of the circle. Can somebody name me one radius? XV, this right here, would be a radius. That's absolutely correct. XV. Let's write that down. What else would be a radius? XU. What else goes from the center to the edge? XT. And what else? XZ, yes. There are 2 chords that are shown in the picture, 2 segments that go, or that have its endpoints lying on the circle. What is one of them? RS is one. And there is another segment whose endpoints lie on the circle. ZT. What is the name of the diameter? It's a chord that goes through the center. ZT, yes. Nicely done. All right, number 3 says TU is 14 feet. What is the radius of circle Q? Remember, the diameter is equal to 2 times the radius. We know that the diameter is how big? 14, because from here to here is 14. So we have 14 equals 2r. Then we divide both sides by 2, and that means the radius is how big? 7. Actually, I should put units with that. What units should I put with the 7? 7 feet, yes. 7 feet equals the radius. Part B, it says LM equals 11 inches. Is LM a radius or a diameter? This is a radius. From L to M, this right here. What is the diameter of circle L? We know diameter is equal to 2 times the radius. So the diameter would be equal to 2 times 11. So how big is the diameter? 22 inches, thank you. Wonderful. Let's turn the page. Circumference. Circumference is the distance around the circle. Distance around a circle. It's the same thing as the perimeter of a circle. The equation for the circumference is C equals 2 pi r. Or, because 2r is the same as d, you could have C equals pi times the diameter. Pi is the ratio between the circumference and the diameter. And before we go on to answering any questions, I also want to give the area formula too. Pi is equal to the circumference divided by the diameter. The area of a circle is pi times the radius squared. All right, let's see if we can answer these three questions here. Traffic circles, also known as roundabouts, are circular roadways that reflow traffic in one direction around an island. A car enters a traffic circle and is 18 meters from the center of the island. If the car drives around the circle until it's back to its original position, what is the circumference of the car's path? So it said that when it enters the traffic circle, it is 18 meters from the center. And so for circumference, we have circumference equals 2 pi r, or circumference equals pi times the diameter. Which one would be the easiest for us to use right now? Do we know how big the diameter is? Do we know how big the radius is? Yes, then 2 pi r would make the most sense for us to use here. So I have circumference equals 2 pi times, how big is our radius? 18. So 2 pi times 18. So now I can take the two numbers, the 2 and the 18, and multiply them together. What is 2 times 18? 36. So C equals 36 pi meters. Or I want the decimal approximation of that because pi is a number. Pi is 3.14159 something, 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 something. Keeps going on and on and on forever. So I want you guys to put 36 pi into the calculator, hit enter, and then you're going to have to hit that button above the enter key so that it will give you the decimal approximation. So 36 and then the pi button, hit enter, and then the back and forth arrows above the enter key. 113.097. And that would be meters. All right, number 6, many automobiles have customized rims that are attached to wheels and align with the inner edges of the tires. The rim of a tire has a radius of 7.5 inches. What is the circumference of the rim? So one more time, we have to look at, are we going to use 2 pi r, or are we going to use circumference equals pi d? Which one makes the most sense here? 2 pi r, because we know the radius. So circumference equals 2 pi times 7.5. What is 2 times 7.5? So this would be 15 pi inches. Or what would that be in its decimal form? 47.124, thank you. So 15 pi inches, that would be the way I would leave my answer if they wanted it in exact form. I would leave my answer as 15 pi inches. If they wanted it rounded, then I'm going to give the decimal approximation 47.124 inches. Number 7. Find the circumference of a circle with a diameter of 27 centimeters. So one more time, circumference equals 2 pi r, or circumference equals pi d. Which one makes the most sense to use in this case? Pi d. Circumference equals pi times our diameter of 27. So the circumference would be 27 pi centimeters, or, yes, 84.823 centimeters. Nicely done. All right. Let's look down at 8 and 9 next. 8, 9, and 10. It says, find the diameter and radius of a circle to the nearest hundredth if the circumference of the circle is 77.8 millimeters. So circumference equals 2 pi r, or circumference equals pi d. It doesn't really matter which one of these we use on this problem because we're looking for both the diameter and the radius. And we know the circumference is 77.8 millimeters. So I'm going to go ahead and use circumference equals pi d. We'll find the diameter first, and I'm only doing that just because it said find diameter and then radius. So I'm just going to go in the order that they suggested. You don't have to do it in that order. Circumference equals pi d, and the circumference there is 77.8. So I'm going to put that in the place of c, equals pi d. What would I need to do to this now to get the diameter by itself? Divide by pi. So I need you to grab your calculators then. We're going to do 77.8 divided by, and then you're going to push the pi button and hit enter. You said 24.765. Thank you. 24.765. Oh, 764, sorry. I heard you incorrectly. You rounded it up? Yeah. Should we put units with that? I don't know. Yeah? What units? Millimeters, thank you. The circumference was in millimeters, and so my diameter would also be in millimeters. Good answer. All right, we still need the radius. We could do one of two things for the radius, but I'm going to go with the shortcut here. We know that the diameter is equal to 2 times the radius. And we just figured out that that diameter was 24.764 or 0.765 if you round it up. And that's equal to 2r. We divide both sides by 2. 12.3, sorry, you said 12 point what? 382, thank you. 12.382. Should we use units with this? Yes, what units? Millimeters. It's equal to the radius. Find the diameter and radius of a circle to the nearest hundredth if the circumference of the circle is 94.2 yards. Let's do this one together, and then I'll have you guys do number 10 on your own. So circumference equals, do you guys want to do 2 pi r or pi d? Pi d, sounds good. Circumference equals pi d. The circumference this time is 94.2. And so then we divide both sides by pi. And what does that give us? You said 29.98 what? 984. Should we put units with that? Yards. Equals my diameter. And then we have diameter equals 2 times the radius. So we're going to put 29.984 in for D. Equals not 2 pi, sorry, 2r. I don't know why I wrote a pi there. Equals 2r. Then we divide both sides by 2. That means our radius is how big? 14.992 yards. All right, I would like for you guys to try number 10 now on your own. I'll check back in with you in about a minute and a half. Sorry, dear. Oh, absolutely. You're welcome. No, that's how you, like, you have this as division. You didn't put division in there. There you go. Hit enter. There you go. You're welcome. What did we get for the diameter? 90.4 feet. Nicely done. And so then what was the radius? 45.2, yes. Diameter equals 2 times the radius. I keep writing pi instead of radius. 90.4 equals 2r. Divide both sides by 2 and you get 45.2 feet. How are you feeling about this so far? You like it so far? Okay. We've got 2 more problems that we're going to look at for today, just 11 and 12, and then we are done and you guys will have time to get that homework knocked out. Number 11, the diameter of circle K is 12 units. The diameter of circle J is 20 units. And JD equals 8 units. Find EK. All right, so the first thing we know is the diameters of these 2 circles. We have circle K and circle J. Diameter of circle J is 20 units, so from here all the way to the edge of the circle there at E is 20 units. Well, if that's 20 units, how big is this right here? That would be 10. So how big would this be from here all the way over to E? Would also be 10. The diameter of the other circle was how much? 12 was the diameter. That would go over to the edge of the circle. Well, if that's 12, how big is this right here? That is 6. Which means from D to K would be how big? Would also be 6. And then the other piece of information they gave us is that JD is 8 units. This right here is 8 units. And we're supposed to find the distance from E to K, correct? All right, so let's look at this real quick. From J to E is how big? 10. And JE is equal to JD plus DE. So I would have 10 equals 8 plus DE. So how big would DE have to be? 2. All right, so coming over here, this little bit right here is 2. Well, I know that from D to K is how big? 6. From D to K is 6. And segment DK is made up of 2 smaller segments put together, DE and EK. Didn't we just figure out how big DE was? How big is DE? DE is 2. So I would have 6, excuse me, equals 2 plus EK. So how big is EK? 4. No formula for that. We just had to do some successive analyses of what information do we have and what are we trying to find. Let's do one more like that to round us out for the day. The diameters of circles Y and R are 18 and 30 units respectively. When they say respectively, that means the first one here goes with the first number here. So the diameter for circle Y is 18. And the second one goes with the second one. So the diameter for circle R is 30. Well, if the diameter of circle Y from here over to here, from edge to edge of circle Y, is 18, how big is each radius? 9. So I'm actually going to take this away so I don't have too much on the picture. This would be 9 here, and this would be 9 here. And then the other circle, circle R, has a has a diameter of how much? 30. So what would the radius be? 15. So from R to T would be 15, and from W over to R would also be 15. Yes. Okay. And so then they tell us also that WX is 6. So this length right here from W to X is 6. Find the lengths of YW and XR. All right, so YW and XR is what we're looking for. Well, I know from looking, excuse me, from looking at the picture that YX is made up of what two smaller segments put together? YW and WX. So YX equals YW plus WX. Do we know the sizes of any of those? Which ones do we know? WX is how big? 6, so I can put 6 in here. Do I know any of the others? YX, how big is YX? 9, because YX is a radius. So I'm going to put 9 in the place of YX. Well, if YX is 9 and WX is 6, how big is YX? YX, oh, I wrote YX right there. I'm getting confused looking at my own writing. YW, yes. How big is YW? 3. Thank you for correcting me. All right, now we still need XR. So what's the big segment that I would want to look at if I'm trying to find XR? RT would be this over here. Is that made up of smaller segments? Does it contain XR? WR contains the segment that I'm looking for. So WR is equal to what smaller segments put together? From W to R. WX and XR. Do we know how big any of those segments are? Which ones do we know? WX is? WX is 6. Remember, right here it says WX is 6. Do we know how big XR is? No, we don't know how big XR is. So I have to... XR? XR? XR is the thing we're supposed to be finding. We don't know that one yet. What do we know, though? WR. We know WR. WR is how big? 15. So what would I need to do to solve this now? 15 minus 6, which would be how much? 9. So XR is 9. So on these problems, the segments that I'm looking for, I go find the segment that I'm looking for. I identify that like XR is right here. And then I find the radius that it is a part of. So XR is inside this circle. So I ignore this circle over here entirely, and I'm just looking at this radius here. And I write an equation that lets me put the two smaller segments together to equal the whole radius there. And then I substitute in the pieces that I know. All right. Your homework is due on Monday.